Section 4.1 examples. All right, in this first example, we're just going to roll a regular die. Now, when you roll a die, your outcomes are 1, 2, 3, 4, 5, or 6. So the probability of rolling a 4, well, when you look at the outcomes, there's only 1 4 out of 6 outcomes. So the probability is 1 out of 6, 1/6. The probability of rolling an even number, well, if you look at your outcomes, we have a 2, a 4, and a 6. So 3 out of the 6 outcomes are even. So the probability of an even number is 3/6 or 1/2. Either way is fine. The probability of a number greater than 2, so that does not include 2. That's the 3, 4, 5, 6. There are 4 numbers out of the 6 that are greater than 2. So 4 out of 6, or 2/3. All right. Now, instead of looking at dice, we're going to look at a deck of cards, just a standard 52 card deck. The probability of a heart, well, there's 13 hearts in a deck of cards, so 13 out of 52. Okay. The probability of drawing a 4, well, there are 4 4s in a deck of cards, so 4 out of 52. The probability of an ace of spades, well, there's only 1 ace of spades in a deck of cards, so 1 out of 52. Okay. All right. In this next example, okay, we flip a coin 100 times and heads occurs 39 times. Based on this experiment, what is the probability of flipping a coin and getting heads? Well, we know when we flip a coin, the probability of heads is 1/2. But since this says based on this experiment, we got heads 39 out of 100 times. So the probability of heads in this experiment is 39 out of 100. Okay. All right. Okay, now, if we flip a coin 3 times, what is the probability of heads, tails, heads? And what is the probability of 2 tails in any order? Well, what makes this problem particularly difficult is that we need more information. We don't know what the outcomes are or how many outcomes there are. So the first thing we need to do is list the sample space. Now, the sample space is all possible events or all possible outcomes. So when I flip a coin 3 times, I can get heads, 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 tails, heads, tails, heads, tails, heads, 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 tails, 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 heads, tails, tail, tail, heads, tail, tail, tail. So these are all possible outcomes if you flip a coin 3 times. Now, our first question asks, what's the probability of heads, tails, heads? Well, this only occurs once out of the 8 outcomes, so that probability is 1/8. Okay? Now, the second probability wants the probability of 2 tails in any order. Well, that's the heads, tails, 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 heads, tails, or the tails, tails, heads. So that occurs 3 times out of the 8 possible outcomes. So the probability of getting 2 tails in any order is 3/8. Okay? All right, our last example. A random sample of 317 new Smile Bright electric toothbrushes showed that 19 were defective. Estimate the probability that a new Smile Bright electric toothbrush is defective. So the probability it's defective, well, there were 19 out of 317 that were defective. So that's our probability, 19 out of 317. Estimate the probability that a new Smile Bright electric toothbrush is not defective. Well, if 19 are defective, then we take 317 minus 19 to get 298 that are not defective. So the probability of not defective would be 298 out of the 317. Okay? All right, what is the sample space in this problem? Well, remember, sample space is just your list of outcomes. So either it's defective or not defective, okay? Do the probabilities add up to 1? Well, yes, they do. If we take the probability of being defective plus the probability of not being defective, that does equal 1. Okay, that's easy to show. Now, should they add up to 1? Well, what you have to ask yourself, did we leave out any possible outcomes? And no, either the toothbrush is going to work or it's not going to work. Okay, that's all of our outcomes. So yes, the probability should add up to 1 because we have the entire sample space. We have all possible outcomes. Okay, let me know if you have any questions, and good luck.